Welcome to September 30th LeetCode Challenge. Partition to k equals some subsets. Given an array nums and an integer k, return true if it is possible to divide this array into k non-empty subsets whose sums are all equal. So we're given this array called sum nums here, and we want to divide into 4 equal subsets that have the same sum. So what are the is it possible? Yes. Here's how. We divide basically into 4 subsets, where this be 5, 1 and 4, which makes 5, 2 and 3, which makes 5, and then we have another pair of 2 and 3, which also makes 5. So divide into 4 subsets. Each of the sums of the subsets equal to 5, which is all equal to each other, so therefore return true. For example, if we have this nums array of equaling to 4 here, forming now 4 elements in it, and we want to make 3 subsets of it that have the same sum, we can't do that with this subset. So the length of nums is less than k, which is less than 1, which is greater than k, then greater than 1, but less than 16. And then nums at I is between 1 to 10 to the 4th. The frequency of each element is between 1 to 4, and the range of there. Let's see the hints here. Recursively search. So yeah, we could do recursion here using a depth first algorithm, but I really feel like we could do this solving it using a little bit of a bit masking and dynamic programming approach to it. Let's see how it goes. So the first thing we want to figure out is basically let's call it find the length of the list first. So it'll be length of nums, and then I think I'm gonna. So the best way to kind of find it in 4 equal parts is actually, I think we're going to sort it in reverse. So I find the largest number, break that down first. If you can make sums from the largest number, then you're pretty much safe, right? So for instance, if you could take 4, reverse sort it, 4 is the first thing, and if you can make sums of it into 3 equal parts, then you could return it, right? So I'm just gonna take nums.sort, and I'm gonna sort it by reverse. Equals true, and I would just reverse sort the list in reversed on the spot here. I don't need to attach it to another variable. And then I'm thinking of making a dynamic programming array and using bit masking for this. So is it possible putting the numbers within a mask in our subsets? So when we return, let's say return -1, that means the partition is not possible. We're going to return, let's say something greater than 0 or equal to 0 if it is possible, right? Which is going to be the something is going to be the remainder, right? If we could divide the sum of all the used numbers so far in our little container, then we have a value that we can make within each group. And then we'll move on to see how that goes. So and the container, I'm going to call it container, call it holder basket, right? Not basket, something to hold a value. I'm going to call it value. And then this is also going to be the remainder. And I'm going to use a function here called the div mod, so division modulus, between the sum of nums and k, right? So basically this is a function that's going to give me the value of the division between the sum of all numbers here divided by k, and then also the remainder as well. So if the remainder is or nums at index 0 is greater than the value, then return false, because we can't make k numbers of subsets that are equal. So that's pretty much it. So once we eliminate that base case out of the way, we're just going to continue with dynamic programming now. So I'm going to create a dynamic programming array. I'm going to set that to -1, and then I'm going to, let's see, star, and then I'm going to use a bit of bit masking too. So basically this is going to be a bit mask, so the possibility of putting numbers into a mask into subsets. So basically every time we return -1, we have a -1 here, then that means the partition is not possible. However, if the remainder is greater than or equal to 0, that means it is possible. So we're going to just go down and make sure we find the answer in terms of changing the neighboring number. And then, so that's how we define a dynamic program, or DP, and then we can make a DP array, or DP index, I should say. So DP at 0, we're going to assign that right away to be 0. So we have everything initialized so far, so we'll just do a simple for loop for the mask here. So for the mask in the range of 1 bit masking by n, for j in range of n, let's say for the neighbor, we assign that to be the dynamic program of the mask I, j. It's funny though, I just actually recently learned this in C for my integrated systems class, hardware class, so kind of using it now, which is kind of neat, I guess, in a way. So if the mask itself and another bit and operation here is one bit shifting is j, and the neighbor is greater or equal to 0, then this is a candidate. And also the neighbor plus numbers at index j is less than the value, which is our main value, then this all meets the requirements for us to update our bit dynamic programming at our mask location to be a valid answer. And to do that, we need to be able to be comfortable in saying that our neighbor plus numbers at index j has to be within the modulus of our value, right? Because it can't be divisible by it. And then this is going to basically equal to a whole number. And then we'll break out of that. That just means we're done. At the end of all this, we want to return our dynamic programming array at index, the last number of that, and if it's only equal to 0, which is going to be true or false, right? So if our last number that we can make from our dynamic programming array is equal to 0, that means that it's true. If it's not, then it's false. Then we cannot make k equal some subsets. Let's give this a run. Of course, I spelled range wrong. And what? This is supposed to be a 1 because we're bit masking with 1, not I. Jeez, spelling this neighbor wrong in the British way. Oh, this is also the same. Oh, sorry guys, this is embarrassing. That looks good. Yeah, so time complexity wise is actually big O of 2 to the n squared. 2 to the n squared. So that's pretty, it's not actually the best solution, but it's there. Because we have a for loop within the for loop that's squared, and we have to do this 2 to the power of n squared times because of our dynamic program array with loop through each bit mask as well. Space complexity is 2n squared. Alright, can store everything in dynamic programming. Alright, that is it. Have a great day, guys.